Today we are going over end behavior, and it's exactly what it sounds like. You need to be able to look at a polynomial and be able to describe what each end of the graph is doing. So the goal is to be able to look at a polynomial and be able to tell me what does this graph do on the left side, what does it do on the right side. Okay, so in order to do this, there's only a couple things that matter, and there are only 4 possibilities. All of these possibilities all depend on 2 things. We're always going to be looking at the first term of each polynomial. This first term will tell us everything we need to know. It'll tell us what the left side of the graph does. It will tell us what the right side of the graph is. So you can think of today like we're creating rules for what a graph does based on what that first term is. Okay, so we're going to do 4 of these, 1 for each of the possibilities. So the first thing you'll always look at, if we're doing this top left polynomial, is you're going to look at its degree. What degree does this polynomial have? In other words, 3. What's the largest exponent? The largest exponent is 3. This is a degree 3 polynomial. And all you have to be able to think about, is that an even number or is that an odd number? Is 3 even or odd? It is odd. Okay, so box odd, or circle. The second thing you have to look at is the leading number, the number that is all the way in the front. The number that's way in the front is 3, which is a positive number. Okay? So this polynomial has an odd degree, and it has a positive leading coefficient. Every polynomial with an odd degree and a positive leading coefficient has the same end behavior. The ends of the graph do the same thing. The middle changes. Okay, so let's figure out what does this graph look like and make a little tiny sketch on our coordinate plane. So calculator is super important today. Pull out your calculator. Turn that bad boy on. Go to your y equals. Let's plug this polynomial in, which is a cubic function, and it's a trinomial. 3 terms, degree 3, cubic trinomial. Okay, let's go ahead and type it in. 3x, you're going to have to use the caret to the power of 3, plus 2x squared minus 3. Make sure it's in. Make sure it looks like your paper, looks like what I have. Now, we don't have to draw a perfect picture, we just want to draw a sketch. So go ahead and click the graph button, and you can see, kind of get an idea of what this graph looks like. Okay? Once you have that graph up, if it's zoomed really far out or zoomed really far in, or you can't see it very well, you can always click zoom 6 on your calculator and it centers it. So my calculator tells me my graph looks something like this. Okay, it doesn't have to be perfect, something like that. So what's important is we do not care what the graph is doing in the middle. We only care what the ends of it are doing, because we're doing end behavior. So we're looking at this end and this end. We don't care what's happening in the middle. You're just looking at what does the left side do, what does the right side do. So what would you say is happening on the left side that I highlighted? What's the graph doing? It's going down. On the right side, what is my graph doing? It's going up. On the left end, it goes down. On the right end, it goes up. Okay, so here it's going down, and on the right side it's going up. Now in math, up and down are not great math vocab words. What should we use instead? So instead of down, where is this going towards? Negative. Yeah, the negatives. It's going down. How long does it go down for? Forever. Negative infinity. Down means negative infinity. Which means up means positive infinity. So on the left side, we're going down towards negative infinity. And on the right side, we're going up towards positive infinity. So we need to be able to write this in like a math notation. It'll always look the same. Okay, we're going to say f of x, or p of x, because this is the function p of x. We're going to do the left side first. P of x goes towards negative infinity. Which way does, when does it go towards negative infinity when we're going to which side? To the left. Okay? As x approaches, now again, left and right are not great words. Yes, this way is left, and this way is right. But instead of left, what should we say? What numbers are we going towards when we go to the left? Negative infinity. Negative infinity. And instead of saying right, we would say positive infinity. So as our p of x, which is our function, goes down forever, as we go towards the left, which we say the left is negative infinity. Okay, I know it's really weird. Whenever we're going to the left, we use negative infinity. Whenever we're looking at the right side of our graph, we're talking about positive infinity. And instead of up and down, we use infinity for up, negative infinity for down. Okay? If we describe the right side of our graph, p of x, which is our polynomial, which way is it going on the right side? It's going towards positive infinity. As x goes towards the right, which is positive infinity. This is our end behavior. Okay? It is weird. We are not used to writing in what's called logic notation. This is how we would write in math, and it just means the same thing in English. This means the function is going down as we go towards the left. The function is going up as we go to the right. Okay? So the only thing that will change every time, okay? The only thing that will change, all of this will be exactly the same. The only thing that changes is this right here. That's the only part that will change. Towards the left side, negative infinity. Towards the right side, positive infinity. Everything else stays the same. These are the only two things that changes. Okay? Because we're going to have to describe what happens towards the left and what happens towards the right for all of them. Okay? I know it's a lot. So we're going to do another one. So whenever a polynomial has an odd degree and a positive number in the front, it will always have this same end behavior. The left side will go down, the right side will go up every time. Okay, let's try the next one. In our next one, what is our degree? Top right. What's the degree? What's the largest exponent? 3. 3 is our degree. Which means, again, we have an odd degree. Odd. However, this time, our leading number is not a positive number. It's a negative number. -4. So it's almost just like the other one. Now, if this would have been a positive 4, it would have had the same end behavior. We wouldn't have even needed to graph it. Anytime you have an odd degree with a positive number in front, it always goes down on the left, up on the right. So let's see what happens when I make that negative. Okay, so pull up your calculator. And let's type it in. Go to your y equals. Clear out that old one. And let's type her in. -4x, gotta use that caret, to the power of 3 plus 2x plus 3. And again, we're just sketching the graph. It doesn't need to be a perfect graph, just a sketch of it. Looks similar. Okay, this time my graph looks something like this. Again, I'm just sketching it. Nothing doesn't have to be perfect, but isn't it almost exactly like the other one? When we look at the end behavior, what's different this time? On the left side, instead of going down, what's it doing? It's going up. On the right side, instead of going up, now it's going down. When that front number became negative, the graph just did this. It's like a reflection. It just flipped. Okay? So again, this is going to be exactly the same. The only two things that change are these highlighted pink. So P of x is going towards, which way is it going towards on the left? Up. So instead of negative infinity, we're going to put positive infinity. This is going towards positive infinity. This is going towards negative infinity. So P of x goes towards positive infinity as x approaches the left side, and the left side is, this is negative infinity. Left is negative infinity, right is positive infinity. So as we go towards negative infinity. And look, nothing changed for all the rest. The only thing that changed was that first infinity sign. That's where our end behavior is. Okay, now if we describe the right side, which it's going down, so we're going to use negative infinity. Polynomial x approaches negative infinity as x approaches positive infinity. Again, it looks crazy. It looks weird. But all this is saying is the polynomial is going down as we go towards the right side. As you go right, this polynomial goes down forever. As you go left, the polynomial goes up forever. That's what that says. Again, the only thing that's changing here is these are our end behaviors right there. The rest will stay exactly the same every time. And what's cool about this is you won't have to do this every single time. We're basically making ourselves a cheat sheet right now. When you look at a polynomial that has an odd degree and a positive number in front, this is going to be its end behavior every time. It doesn't matter what the polynomial looks like, long or short. If it has an odd degree and a positive number in the front, it's going to have this end behavior. Down on the left, up on the right. Anytime it's an odd degree and a negative number, it's going to be going up on the left and down on the right. Those will stay the same every time, as long as you can look at the degree and leading number. Okay, 2 to go. What is my degree of my bottom left? 4. This time, our degree is even. It's even this time. And our number in the front is positive. So just like the one above it, except for our degree is even now. So let's see how this changes our graph. Okay, so pull up your graph. Go to your y equals, clear out that old one. We have 3x to the power of 4 minus 5x squared plus 2x minus 6. Take a look at your graph. Look at that, crazy guy. Again, we don't care what's happening in the middle right now. We only care what happens on the ends. But this, it looks like a funky W. Okay, so if we sketch our picture, we got something like this. No, not beautiful, but it does the job. Yep. And now, all that matters for right now is we just want to make sure we know what the graph is doing on its ends. The middle, we'll worry about later this year. We only care about what's happening right here and here. Those are the ends. Now you notice, where are both of our end behaviors going? They're both going up. So both of our end behaviors, where we highlighted the part that changed, are just going to both be positive infinity. Okay? Because remember, if you're going up, it's positive infinity. If they're going down, it would be negative infinity. Left is negative infinity. Right is positive infinity. So this graph, we have p of x approaches positive infinity. And again, p of x approaches positive infinity. So both ends are the same. As x approaches the left, negative infinity, and as x approaches the right, positive infinity. Okay? So the left side goes up, the right side goes up. That's what that mumbo-jumbo means. So we've done 3. We have one that goes, it goes down and then up, one that goes up and then down, one that both goes up. Which one haven't we done yet? I bet it's both goes down. Okay. Now if we look at this one, it's the same thing. Here we have an even degree. And we have a negative leading number. Even degree, negative leading number. I'm willing to bet my life on it doing the one we haven't done yet, but we'll just graph it to be extra safe. Clear out your old one. Let's type in our last one. Ooh, to the 6th power. Negative 2x. The power is 6. plus 5x squared plus 2x plus 4. Do your graph. What do you know? Both the ends look like they're going to be pointing down. Again, your sketch doesn't have to be a masterpiece or a work of art. Just make sure it gives you the gist. We don't care what goes on in the middle of our graph. All we care about is what's going on the ends. So our end behavior, what are both of our ends doing? They're going down. But in math, we don't say down. We say negative infinity. It's going towards the negative numbers, down forever. So it's going to be exactly like that one we just did, except for instead of going towards positive infinities, it's going to be going towards two negative infinities. So both ends, p of x approaches negative infinity. X approaches the left side as x approaches the right side. So it's important to understand that these are the only four possibilities for end behavior. These are the only four. You don't even have to graph it if you know its degree and its leading number. If its degree is odd and its leading number is positive, it will always have this end behavior. So this is like a cheat sheet. If it's odd and negative, it will always have this. It doesn't matter how long the polynomial, how crazy it looks. If the degree is even and the number in front is odd, your graph will always point up on both ends. Okay? So those are our four little possibilities.